It's becoming less and less like a normal comet. The latest high-resolution images of 3I Atlas have exposed something extraordinary, a jet of material erupting from the object itself. And this jet doesn't just stretch for thousands, but millions of kilometers into space. That's why the data recorded on November 9th stands as one of the most astonishing and perhaps unbelievable discoveries ever made about 3I Atlas. For an interstellar visitor already shrouded in mystery, this takes everything to an entirely new level. And according to Avi Loeb's analysis, the math behind what we're seeing simply doesn't make sense in the laws of physics as we know them. So now, let's dive deeper into what might be the most shocking revelation yet about 3I Atlas. The first images showed one massive jet aimed almost directly toward the sun, stretching over 1 million kilometers in length. Then another jet appeared in the opposite direction, extending nearly 3 million kilometers outward. To put that in perspective, the distance between the Earth and the Moon is only about 400,000 kilometers. These jets are over 7 times that distance. Imagine something stretching across that vast span of space, glowing with reflected sunlight and charged particles shooting from a single interstellar body. It's breathtaking. Back in July, the Hubble Space Telescope had already captured 3I Atlas. Back then, it showed a faint compact halo, a soft glowing blur just a few thousand kilometers across. But now, these new images from November show something 3,000 times larger, 3,000 times bigger in just a few months. That kind of transformation isn't just dramatic, it's physically shocking. Ordinary comets don't behave this way. Usually, when a comet approaches the sun, it forms a single, elegant tail pointing away from it. That happens because of the solar wind, a constant stream of charged particles blasting outward from the sun at hundreds of kilometers per second. It acts like a cosmic leaf blower, sweeping gas and dust off the comet's surface and flinging it backward through space. So when you look at a comet in the night sky, that shining tail always points away from the sun. But with 3I Atlas, we're seeing something that breaks that rule. Jets pointing toward the sun. Jets that seem to resist that powerful solar wind and stay coherent over distances of 1 million kilometers or more. For a jet to remain that straight, that dense and that stable, while pushing directly into the flow of solar radiation, it must be incredibly powerful. That's not normal cometary behavior. Now, rare exceptions do exist, things called anti-tails, when geometry or timing makes it appear that a tail points toward the sun. But even those are short-lived optical illusions. What's being captured here doesn't look like an illusion. It looks like real opposing jets, sustained and massive. This has made scientists dig through the record for possible parallels. Back in 1992, a comet called Shoemaker-Levy 9 ventured too close to Jupiter. The gas giant's immense gravity tore it apart into 21 separate fragments. When those fragments slammed into Jupiter in 1994, they left behind black scars larger than Earth scars that remained visible for months. That event showed that fragmentation can release massive bursts of material far beyond what a single nucleus could normally produce. Then there was Comet Holmes in 2007. Practically overnight, it brightened by a factor of 1 million and created an enormous expanding cloud of gas and dust visible to the naked eye. At first, astronomers thought it was a collision or some exotic explosion, but it turned out to be a massive outburst, an internal pressure buildup that caused the comet to fracture and vent material violently into space. Both of those were completely natural events, but both involved comets breaking apart. And that might be exactly what's happening with 3I Atlas right now, a massive interstellar comet fragmenting under the stress of sunlight and internal heating. Each fragment, now acting on its own, could be releasing jets of gas and dust that combine into the colossal plumes we're seeing. But here's the problem. When Avi Loeb and his team ran the numbers on these jets, the results came out nearly impossible. Based on their brightness and estimated density, 3I Atlas would need to be losing roughly 50 billion tons of material per month. Let that number sink in. 50 billion tons every 30 days disappearing into space. Now, through orbital tracking and gravitational modeling, astronomers estimate the total mass of 3I Atlas at about 33 billion tons. That means that according to the math, this comet is losing more mass per month than it actually weighs in total. If those numbers are even close to correct, it simply shouldn't exist anymore. It should have completely evaporated weeks ago. So how can this be possible? The short answer is that it probably isn't, at least not in the straightforward way we'd assume. Loeb himself noted that the numbers might not add up because we're not dealing with a single intact body anymore. It's possible that 3I Atlas has fractured into hundreds, maybe thousands of smaller pieces. Each of those fragments would have its own surface area exposed to the sun, meaning exponentially more material can sublimate that is turned from ice to gas at once. When you break something apart, its total surface area explodes. Imagine smashing a large block of ice into snowflakes. Suddenly, every bit of it can evaporate faster. The same principle applies here. If 3I Atlas has shattered into a swarm of icy fragments that could explain the insane jets, the massive rate of material loss, and the scale of the glowing debris cloud we're now seeing. There's even a precedent for this kind of misleading math. When Shoemaker Levy 9 broke apart, scientists noticed that the amount of gas and dust released during the impact was much greater than the estimated mass of the comet itself. Only after accounting for all the fragments and secondary explosions did the math start to make sense. Still, this doesn't fully solve the mystery, because so far no telescope has confirmed visible fragmentation in 3I Atlas. The jets could be coming from a solid single object, which would make the situation far stranger. If it really is intact and still producing millions of kilometers of dense structured jets, then it's doing something no natural object should be able to do. If that turns out to be true, this would be the first time in recorded history that we've seen an interstellar object defy conservation of mass on this scale. Something that challenges the limits of physical explanation. As Loeb puts it, extraordinary claims require extraordinary evidence, and this would demand exactly that. But even that's not the end of 3I Atlas weirdness. Because when astronomers plotted its orbit, they found another anomaly, one that makes this object even more of a cosmic oddball. 3I Atlas isn't just shedding material in bizarre ways, it's also traveling through the solar system backwards. Almost every planet, asteroid, and comet we know moves around the sun in the same direction. Counterclockwise if you're looking down from above the sun's north pole. That's the direction inherited from the spinning cloud of gas and dust that formed the solar system 4.6 billion years ago. Everything from Earth's orbit to Jupiter's, even most comets, follows that same flow. But 3I Atlas is the rare exception. It's moving clockwise. In astronomical terms, we call this a retrograde orbit. Only about 1 or 2% of known objects travel in this direction, and nearly all of them are captured moons or fragments that got gravitationally tossed into strange paths long after the solar system formed. For an interstellar visitor, something that came from outside our system to have a retrograde orbit this precise is extremely rare. And it's not just the direction that's odd. The path of 3I Atlas is almost perfectly aligned with what's known as the ecliptic plane, the thin, flat disk where all the planets orbit. Now imagine a rock from another star system coming in from far away. Statistically, it should approach from above or below that plate at some random tilted angle. But 3I Atlas didn't. It came in along the plate as if it were following the same invisible track as the planets themselves. The chance of that happening randomly, about 0.2%, roughly 1 in 500. It's so precise that some astronomers have started wondering if 3I Atlas might not just be an accidental traveler, but an object with a trajectory influenced by something else. Gravity, sure, but perhaps something more complex too. This pattern is strikingly similar to what we saw in 2017 when another interstellar object, Oumuamua, zipped through the solar system. Oumuamua was small, no more than a few hundred meters long, but its behavior was just as puzzling. Its brightness changed erratically, as though it was shaped like a thin, tumbling pancake. And as it left the sun's vicinity, it accelerated slightly more than gravity alone could explain. Avi Loeb was one of the few scientists who dared to suggest that Oumuamua might not be natural. He proposed that it could be a light sail, a thin, broad structure pushed by sunlight. Perhaps the debris of an artificial craft from another civilization. Most astronomers dismissed that as unlikely arguing. It was more plausible that Oumuamua was made of exotic ice, perhaps hydrogen or nitrogen, which would sublimate invisibly and cause the odd acceleration. Still, no one has ever fully settled the debate. Now, with 3I Atlas, those discussions have reignited. The difference this time is scale. Oumuamua was tiny, lightweight, fragile and fleeting. 3I Atlas, on the other hand, is massive, over a mile wide, weighing billions of tons and moving in that rare retrograde orbit right along the ecliptic plane. The odds of an interstellar object arriving with this combination of properties are vanishingly small. And the more we look at it, the more it seems to resist simple explanations. Could 3I Atlas also be accelerating in subtle ways that defy standard cometary behavior? Its possible early tracking data shows slight deviations from purely gravitational motion, just like Oumuamua. But in this case, the deviations are far smaller, harder to confirm, and buried beneath the immense outflow of material from those million-kilometer jets. If there is any non-gravitational acceleration, it's likely masked by the noise of all that activity. Still, the numbers are compelling. The energy required to maintain jets of that length, jets that push both with and against the solar wind, is staggering. The sheer density of the ejected gas must be enormous. And yet the object remains coherent enough to stay on course. It's almost as if something inside is regulating how much material escapes, keeping its shape balanced despite the chaotic forces ripping across its surface. If 3I Atlas has indeed broken apart, we might eventually see its pieces scatter, each following slightly different paths around the sun. But if it remains a single object, solid, stable, and still producing these immense symmetrical jets, then we're witnessing something unprecedented in all of cometary physics. No known mechanism could allow a comet to lose more mass than it contains and still remain whole. That's why astronomers are watching it relentlessly. No one is claiming it's artificial. Not yet. But if it continues to behave in ways that physics can't fully explain, if it keeps shedding material faster than possible, or if its jets remain impossibly structured, then the debate will inevitably grow louder. For now, scientists are cautious. The next few months will be critical as 3I Atlas continues its journey past the sun and back toward interstellar space. If the jets fade, well know it was a natural outburst from a crumbling object. But if they persist steady, symmetrical and strange, then we might have to start asking bigger questions about what's really out there traveling between the stars. Whatever the final answer is, 3i Atlas has already earned its place in history as one of the most puzzling and dramatic interstellar visitors we've ever observed. If you found this story as incredible as I did, make sure to leave a like and subscribe, because whatever happens next, it could redefine everything we know about how our universe works.